My name is Dina Haritos Tsimitis, and I'm director of Carnegie Mellon's Information Networking Institute. And as you may know, but if you don't know, the INI, or the Information Networking Institute, is celebrating its 20th anniversary this weekend during Carnival. And I want to give you a brief overview of what INI is. INI is a department in the College of Engineering that offers graduate programs in information networking and security in Pittsburgh, Pennsylvania, bicoastal programs with Silicon Valley, and programs around the world in Kobe, Japan, Lisbon and Aveiro, Portugal, and Athens, Greece. INI was established 20 years ago, pretty much triggered by the demand from industry. And our moderator today, Marvin Sirbu, will give us some background information or tell the story about how INI was founded. But from the beginning, INI was established as an interdisciplinary field of study that would draw on the fields of electrical and computer engineering, computer science, public policy, and business management, a blend of expertise that is still valued by employers today. Today, the INI presents two panel discussions on mobile communications and internet security. The first panel will be presented now. Will emphasize the evolution of telecommunications to mobility and will be moderated by Professor Marvin Sirbu, who is the founder of INI. The second panel, which starts at 3:45 in this same room, will focus on the work in the areas of security and privacy and will be moderated by Pradeep K. Khosla, who is the Dean of the College of Engineering, the founder of CyLab, and former director of the INI. And I'd like to begin now by introducing our first panel, along with our moderator, and then ask the panelists to introduce themselves. So the panel's titled Introduction, it's called Evolution from Telecommunications to Mobility. Learn how a 1980s partnership with a telephone company grew into a launchpad for the CyLab Mobility Research Center and other emerging technology initiatives. Marvin Sirbu, again, who I mentioned, was the founder of INI, is a professor of engineering and public policy, industrial administration, and electrical and computer engineering. He's been at Carnegie Mellon University since 1985, and in 1989, he was the person who led the founding of INI. He wrote the proposal to Belcore, and I'll let you tell the story, Marvin, because you tell it so well. So let me hand it off to you. Thank you.
Okay. You have to visualize what the world was like in 1989. We had a telecommunications industry. It used to be dominated by Ma Bell, but Ma Bell had just broken up into AT&T and 7 regional Bell operating companies. But that industry was completely separate from the computer industry, the software industry, dominated by companies like IBM and Digital Equipment Corporation. And the notion that there was something that like distributed systems where you actually had to understand both communications and software was a remarkably novel idea. It was sufficiently novel that Belcore complained that it couldn't hire any people who knew both of those things. And so they wrote to a number of universities and said, would somebody please create a program that combines software and communications, and it probably should have some business so that people actually know what to invent rather than just the technology. And if you create such a program, we'll send a lot of our new hires to it because we need people who are trained in those fields. So with some financial help from Belcore to get started and a slew of students that they financed to come in the early years, we began the INI with its master's program in information networking that combines precisely those fields. The program has continued to evolve over the years. Belcore has long since disappeared as an entity, swallowed up by Telcordia and then SAIC. But the idea of computers and communications being important, remember 1989 is before the invention of the World Wide Web. It's TCP/IP was a plaything of a few academic universities. No businesses used it for anything. And all of the things that we take for granted today, information on the web, electronic commerce, and so on, were all still to be invented, in many cases by graduates of the early INI programs. So we're still here and still trying to invent the future wherever that is going to take us, but built on the technologies of communications, distributed systems, software, and business. And we'll hear some of that evolution in the activities of students over the years from our panel. So without further ado, I'm going to begin and ask Jesse Schell to lead off. Jesse is a graduate of the class of 1994, is it?
It would have been 93.
93,
yeah,
1993, the fourth class of the INI, and is, after going off and working in industry, has come back to CMU as a faculty member.
Right, yeah. So I was one of those guys at Belcourt, as a matter of fact.
Mm-hmm.
What happened to me is I'd been at Rensselaer studying artificial intelligence, and I had a dream of having someone send me to graduate school. And so every job I applied for, I said, and who wants to send me to graduate school to study artificial intelligence? And they all said, no, that's crazy. That's not going to happen. Except for Belcourt, who said, well, we used to do that a lot, but now we only do it for computer networking. And I thought, computer networking? Who wants to do that? Nobody wants to do that. That's boring. And remember, this is 1992, before there was the web and that kind of thing. And I had to go away and think about it. And I remember going away and thinking, when I would go to think about things, I like to play pinball. And I remember playing this pinball game and thinking, do I really want to do this, computer networking? It's not really what I'm into. Well, you know what I'd really like to do? Build stuff like this pinball machine. Yeah, that'd be really cool. Now, how would I do that? I thought as I sat there playing pinball. Well, let's see. There's all these sensors, and then they collect data, and they communicate to each other over wires. Oh, damn it, it's computer networking. Right. And so that was how I decided I'd go to the INI. Anyway, since then, I've done a few different things. I was at Disney's virtual reality studio. I was a creative director there. I since came back to Pittsburgh in 2002, started teaching at the Entertainment Technology Center, where I teach game design. And I opened a video game studio here in town called Schell Games.
So I think what'll, Priya, our second panelist is going to be Priya Narasimhan. I can never pronounce it properly. Apologize. We just call her Priya around here, who's an associate professor in electrical and computer engineering and director of CyLab's Mobility Research Center.
Sure. Hi, I'm Priya, and my background is I was born in India, raised in Africa, in Zambia specifically. Then I went to Santa Barbara, UC Santa Barbara, for my PhD. I came to Pittsburgh, and until then I'd never seen a football game or a hockey game in my life. Didn't know about the sport, didn't care about either. Came here, fell hard for both sports, so a lot of my research revolves around sports technology, and I hope I'm going to get to talk to you about that in a bit.
Okay. Our third speaker is going to be Marachel Knight, who is a graduate 1996 from the INI and currently at AT&T.
Good afternoon. I'm Marachel Knight, and as Marvin indicated, I'm currently with AT&T, and I'm actually one of the recipients of the scholarship when Belcourt and the other regional Bell operating companies were sending students here and employees here to INI. And it was a very rewarding experience for me. It has allowed me to evolve, as we're going to talk about the evolution of telecommunications. AT&T as a company has evolved, and with that has my career. And I've been a part of AT&T for almost 15 years. June 1st, I'll be celebrating 15 years of service with what's now AT&T. Started out as Southwestern Bell, actually. But I think I really helped to shape my career. We'll talk about some of the things that have happened. I'm currently supporting our wireless entity and doing engineering program management, and so I look forward to talking to you more.
And finally, Asim Smailagic, who is with the professor. He's a research professor in electrical and computer engineering and at the Institute for Complex Engineered Systems, and director of the Laboratory for Interactive Real-Time Computing Systems.
Thanks very much, Marvin. It's a great pleasure to be on this panel, and I will be talking later about some of the research projects that INI students participated working with me that shaped I can say the history of and future hopefully will be shaping as well of mobile computing and provide some pretty strong arguments behind that. Namely, I have been working with I&I students for over 15 years, and some of new areas and concepts in mobile computing have started here at Carnegie Mellon. Part of that was I&I as well, like wearable computing, context-aware computing, pervasive computing. We did first projects on all of these areas in computing that you are now pretty much used to here, but probably didn't know about this. And I will tell you also about the projects that have research agenda for another 10 years in the area of mobile computing.
Great. So this is our panel, and we'll ask each of them to say a few words now that we've introduced them, and again, we'll start with Jesse.
I'm just saying a few words.
No. I mean, tell us. This is your opportunity. We have about 10 minutes for each panelist.
All right.
And, you're on.
All right. Anything special I should talk about?
Well, as I said earlier, talk about the evolution of the kinds of things that maybe you did when you were here in '93, and the kinds of things that people are doing now, and
okay.
That will be interesting.
Yeah, sure. It's really interesting to look back at how the world has changed since I was an I&I student. Again, yeah, I remember it was pre-web. Thinking about being at the I&I pre-web is very strange. In fact, I will never forget the day I'd been at the I&I, I don't know, maybe a year or something, and one day Marvin says, hey, come over here, check this out. And I'm like, what is it? He says, it's this thing called Mosaic. Look. And here it is. It's the first time I ever saw a web browser. It was down there at Hamburg Hall, and I'm like, what? So what is it? You're like, well, there's a lot of physics papers, and it's mostly, I don't know, at that time it was just physics papers, weather data, and pornography is all there was up there. Right. But Marvin's like, I think this is really going to go somewhere. And turns out he was right. He was right about that. Anyway, so things have changed an awful lot, but for me, the way so we were just having discussions this morning about the I&I and how it's changed over the years, and it's interesting to me in a lot of ways how much it hasn't changed, about how some of the students get on board with with research projects that are already kind of taking off, and then some people start on new ones, and how much it matters what came before. And I got involved in virtual reality. It was really, the I&I was my introduction to virtual reality, which has ended up setting kind of the whole pathway for my career, because one team of students the year before had done an experimental virtual reality thesis, and I just thought that sounded really cool. So I just started digging around, trying to find out how did they do it, who did they work with, did there want to be follow-up work, and it was Professor Loeffler over at the Fine Arts School who was, I went to him and I said, hey, you're doing this virtual reality stuff. What are you doing? He says, well, we're doing the Virtual Reality Art Museum. I said, wow, what does that mean? He says, I don't know. I said, well, do you need network programmers? He says, yes, I think so. He said, yeah, because I've told people we're going to do an exhibit where we simultaneously are exhibiting, we're going to have a connected exhibit where one of them's in Japan and the other one's in Germany at the same time. I think I'm going to need some networking guys for that. I said, oh, okay, all right, so we'll try and figure it out. And yeah, from there I ended up going back to Belcor, and it was one of the things that's just really interesting, just about the continuity of the program. So the program was really, the I&I, as I understand it, was initiated by, I never remember the guy's name. It was
Erwin Doris.
Yes, right, and he was a VP at Belcor, and his as you'd mentioned, his big frustration at Belcor was he said, we have three kinds of people here. We have electrical engineers, computer scientists, and MBAs, and none of them can talk to each other. We need some people who can bridge the gaps. And he got this thing going, and then he retired. And so, when we all got back, we kept track. There were 36 of us got back to Belcor. There were no strings attached for us when we returned. So here we got free ride to graduate school, no strings attached when we returned. One of us left each month. I was the 18th to leave, and I left after a year and a half. So I was right on schedule with that. Because the company didn't understand and appreciate what they had. They had these people who'd come and had this study, but they were not. It wasn't appreciated. They weren't put in where they were because, unfortunately, there wasn't follow through. However, I mean, it's certainly to the program's credit how much it's continued to sort of grow and thrive. Anyway, I was recently speaking to I&I students because there is so there is not a lot of understanding, I think, in the academic world about the importance of computer networking when it comes to the modern video game experiences. The game experiences now are becoming, they're almost all networked. They're almost all networked in novel and unusual ways where you have situations where so many people are connected. And people often think of games as trivial, but you look at a game like Farmville where you have 90 million players who are all interacting. And that's often much larger than your typical network simulation. And so one of the things I'm kind of working with the I&I a little bit is to kind of help people understand this better, because we have this weird situation where the computer gaming industry is just dying to get talented network programmers in, but network programmers don't seem very interested in the game industries. They don't see it as a viable pathway for some reason. So there's a disconnect there. But I've just had a fascinating time working with the virtual reality stuff, working with massively multiplayer gaming, and now getting into the arenas of social gaming and the things that are happening with mobile. It's a very exciting time because everything's getting reinvented.
Well, it's interesting that you say that because gaming has been a driving factor in computer science for 30 years. When the very first visual display computers came out, the Alto from Xerox PARC, you could play a distributed version of Asteroid game on them. Right. And the computer science department I was in at the time actually thought it was a nefarious plot to suck up all the time of everybody so that they wouldn't be as productive and competitive with Xerox PARC.
My grandfather was actually a programmer on ENIAC back in 1948. And I believe he may have created the first computer game. He helped move it because they moved it from University of Pennsylvania to the Pentagon, and he was responsible for helping to get it put back together and testing it. And some of the test programs he wrote were games, and so it's funny. It is innately tied.
And in graphics, certainly graphics, the state of the art has been pushed by gaming requirements, and now networking for vast multiplayer games.
Yeah, as well as mobile. Yeah. I mean, if you look, what's making money on the App Store? You know, it's
games.
It's games, yeah.
All right. Bria.
Sure. So I see quite a few people here in this room whom I've taught. Thank you for taking my classes. Thank you for not sleeping through them when you did. I see some of you whom I'm lucky enough to continue working with, like Patrick Lanigan over there, who's, raise your hand, Patrick, so people can know you and I can embarrass the heck out of you, whom I'm lucky enough to work with on his PhD. So he came through the I&I program and he's working with me on his PhD along with General Motors. So thank you to all of you who've made my life very fulfilling for the time that I taught here. As for what I do right now, as I said, until I moved to Pittsburgh, didn't really know much about sports. I came to Pittsburgh and fell very hard in love with football and hockey. And this is, again, an example of what CMU can do to you. Not the football part, but the fact that you can pursue your own interests and you can pursue interdisciplinary things. So once I started watching football, I would throw things at the TV when a call didn't go the Steelers' way. And you start thinking, this is a problem. This is a real problem. For me, at least, it's a genuine problem, right? And how do you go about solving that problem? And I teach embedded systems for a living. So you start to think, how do you put these two things together? And so immediately the idea comes, why don't you put a chip in the football so you can tell where the football lands, 4th and inches versus a first down. So we went down that path and started doing exactly those kinds of projects for the last 3-4 years. And as much fun as it sounds, it's really, really, really hard. And the reason it's hard is most of the technologies out there in the networking industry or the wireless industry for doing localization, which means how do you know where something is, are within feet range, yards range. Football is a game of inches. Nothing is as demanding as that in terms of you've got to localize the ball. And here's where it gets even more fun. there can be umpteen players on top of it, and the guy at the bottom of the pile is going to nudge it over, right? And you've got to be able to make that decision that the ball actually landed in the right place. And for those of you who watched last year's Super Bowl, the NFL commissioner actually in his pre-Super Bowl press conference said, hey, someday we're going to have a chip in the football. I hope that comes from CMU. Right? And so we started building things like that. We put we put sensors into anything that moves. Let me put it that way. We put it into, vests of football players to know whether they're ready to go back and play after concussions. We've put it in helmets for the same reason. We've put it in gloves to know whether the guy wobbled the ball. Again, one of those things that I get really mad about and throw things at the TV for. So, put sensors into gloves so we know whether he's wobbled the ball, whether he has possession of it, control. Put things into shoes so we can help a punt kicker kick better. Because again, we also think about high school players and junior players, right? I mean, there are a lot of kids want to go out and become the best punt kicker out there, but they can't afford to hire the coaches to do it. But if they could actually get the data independently and know how good they are, they can make that decision and take that data to the coach, right? So we've looked at things like that. And then again, following my love for sports more in the mobility space, I used to go to a lot of hockey games, and I always got cheap nosebleed seats. I still get cheap nosebleed seats. And when I'm in a cheap nosebleed seat, I mean, all of you can see how tall I am when I stand up. I'm not so tall. And there's always a tall guy in front of me who stands up and cuts my view of the goal off. Then the Jumbotron guy decides how I should see a replay. I think these things are unfair, right? And again, you've got to decide how you take technology and try to solve that problem. And again, we started thinking, how do you solve that problem? Well, let everyone have their own personal broadcast. Let everyone decide how they should see a replay, which angle they want to watch it. Let them see the sweat on the player's face if they want to see it. Why should only the Jumbotron guy see it, right? And so we started thinking about that, and really the solution to that, if you step back from it, is large-scale live mobile streaming indoors, and no company out there has done it yet. We're the first to have done it, actually piloted it for the Pittsburgh Penguins, a local hockey team, and actually piloted through an entire 70 games of a season. And actually proven that this can work, and now this has an interest from NFL teams, NBA teams. It's getting deployed everywhere. It's also under consideration for the Olympics in 2012. I mean, so it's amazing that this little thing that can come out of what you love and finding pain points in things you love, and CMU giving you the license to go off and dream up these things, and students willing to take a shot on you to go work with you to do this, that's where it can take you.
Thank you very much, Priya. Marachel.
Yes, so I get real excited hearing that. One of the things that I'm doing with AT&T is I'm with the Antenna Solutions team, and one of the issues that we're having, and my sole purpose in life at this moment, is to get AT&T wireless solution and coverage and capacity into public venues, Heinz Fields, stadiums, convention centers, where when you put 100,000 people in Cowboy Stadium, the wireless network is rather interesting to see those statistics come Monday morning, to say the least. And so one of the things that makes that a challenge is this type of research, or things like the iPhone. When everybody pull out their iPhone and something happens at the game and they want to send some video they've captured, or they want to send some picture that they've taken across the network, back across the internet to a friend that's sitting at home, that creates some real challenges for us on the mobile network. And as these type of applications become more prevalent, we as a company and as a provider, to increase our customer experience, really have to solve that problem. One of the things that I find interesting, this is my first time actually seeing Asim since I left, and my senior thesis to talk about this evolution while I was in I&I was actually working with him, and we were doing a wireless, at the time the application that we were working on was to help technicians, if they were going out to do repairs, they couldn't carry binders of graphics, but if they're out in the field, how do we get those graphics to them remotely? And that was in 1996. And so over time, it's been a very interesting phenomenon in the telecom industry to kind of see that evolve. When I left on, though I'd done the wonderful research in wireless, I actually went back to AT&T, Southwestern Bell at the time, to do advanced intelligent networks, where we were trying to like simple things that we take for granted right now, like caller ID, and pull those off of the switches and put them in central locations. But as you hit the databases and servers, how do we get that transmitted properly across the network? And so over time, I did that, and then I did internet, and now I'm back in wireless trying to help solve this capacity and coverage issue when you have lots of people with wireless devices, whether it's the iPhone or hopefully one day the device that can give you instant replay and every customer want a different angle, those digital dugout kind of features. So it's been interesting, and I&I has definitely been very instrumental in that. We talk about the business aspects of that, and Jim talked about who can bring the computer sciences and the engineers and the MBAs all together. And I think we're only probably half there. I still kind of wonder what our marketing team's thinking sometimes. But it does help me to have been at I&I to be able to use those interdisciplinary skills. I've done engineering. I managed our network operations center for about 18 months, and that's always interesting. And whether you're talking, millions of DSL customers, or you have the Bank of America traffic going across the network and they want it up every time someone wants to hit the server, right? And so it's been a very good experience, and I can't say enough and for Asim and Marvin, Dina, and the people at I&I that just kind of helped me launch my career, and whether I was trying to draw upon technical skills or business skills. I've managed $500 million portfolios for AT&T, so it's been a good experience.
Thank you very much.
Thank you. Asim.
Thanks, Marvin. Yeah, thanks, Marsha. It was a great experience, and I was very, very happy seeing you today after 15 years almost. Yeah, just to build on that a little bit, it was a project where a student did wireless transmission of audio and video, accessing legacy data or databases for, now it's called Bombardier, at that time, Atrans, which was a subsidiary of Daimler-Benz here in Pittsburgh. Manufacturing, as you probably know, they are the largest manufacturers of those airport trains and some other high-speed trains in North America. At that time, they were a subsidiary, as I said, of Daimler-Benz. And how visionary that project was in 1995 and 6, perhaps the best illustration is that I was invited to give a talk about that project in 2003 at the World Congress on High-Speed Trains and Euro Trains. I think that was the name of the event in Madrid, Spain, which was opened by King of Spain. So it was 7 years later. A couple of the other projects that happened at that time, and I&I students took place, and they are pretty visible. There are a lot of publications about them, are augmented reality projects for wearable computer and augmented reality projects for Boeing and electric boat. For Boeing, clearly it was applied to airplane maintenance manufacturing. For electric boat, nuclear submarines maintenance and manufacturing. At that time, augmented reality was, those were probably first or among the first projects in augmented reality and wearable computing.
You can tell everybody what augmented reality means.
Right, so that meant not only overlaying parts of the aircraft skin or construction on the heads-up display, but also doing registration, so that depending on where a person views which part of the plane, a wearable system brings up appropriate schematics and imaging, just depending on your location. And location of the where you're viewing the plane was within, head tracking was within 1 millimeter accuracy at that time. So system automatically from wearable computer on your belt brings up schematics, images, drawings, information that you need to repair or construct the airplane or to maintain the airplane. Now you can imagine at the Boeing site near Seattle at that time, if an engineer needs manual, they might be taken by somebody else, or even if you pick it up it's 100 yards away from you, you need to find drawing or schematics that you need. Now you can calculate how much time you need for that. So it still sounds visionary nowadays, but in 96, well, this project with Boeing started actually in 92. So in 94, we had system in place that we demonstrated at Boeing with these capabilities. The project was funded by NSF and DARPA, and Boeing was co-sponsor. Similarly, for electric boat for nuclear submarines, now just applied for submarines. Each submarine has, at least at that time, 400 different valves, and now you can imagine how to manage their construction and the integration with the main bodies. Again, we built a wearable computer, wireless communication capabilities in pretty tough environment, because submarines spend a lot of their time, as you know, under the water. And another very interesting, very, very complex project that we ran at that time. Now, I believe, just going forward, one of the first cell phones or context-aware mobile phones called Sensei was also done at CMU in 2002 with participation of I&I students. And there are journal conference publications about that. It's still visionary what was done there. The cell phone was able to understand, for example, that you are at a conference, sitting, discussing, engaged in communication, so nobody can interrupt you via phone or show up on the door and trying to grab your attention. If somebody calls you, the cell phone was able to even understand at that time level of your engagement and ask the person to call second time in 3 minutes or 15 minutes. In conjunction with GM project, that system was also able to track your position, and if you are meeting with me coming from Pittsburgh downtown in 10 minutes and you have traffic and all other conditions on the road, the system was able again to understand if you can't make it, if you are nervous, and again put an incoming phone call into the voicemail queue. So those capabilities we had in 2002. When Prince Andrew of Great Britain came to visit Pittsburgh, he came for a conference in 2003. The only demonstration he wanted to see was a demonstration of the Sensei here in Pittsburgh. Then recently we have a couple of the visionary projects, and let me just mention one of them, which are somehow shaping, I believe, the agenda of the mobile computing in the next 10 years at least. We are putting physiological sensors on a chest band, including EKG, respiration rate, heartbeat rate, of course, accelerometer, which is not physiological sensors. I think I mentioned all of them that can track your vital signs and provide other indication about your stress level. But then that indication goes onto your mobile phone, because we are now running on Android's support vector machines library, SVM library, which was pretty much unthinkable, a couple of years ago. And on the cell phone, calculating your stress level. And of course, indication with appropriate advice or warnings what you should do to minimize or reduce your stress level. And that's one of the, I believe, futuristic application of the cell phones anyhow. In medical applications, and this is just one example where they can nicely indicate your stress level. Again, I have I&I students engaged on that, and I'm glad to say that I&I students over all these many years have contributed a lot to shaping history and, I believe, future also mobile computing.
There have been more than a few projects that Asim has been involved with. I remember one where he was developing one of the first sort of handheld computers that ran a full computer operating system. And a group of students from the I&I took that and wrote the first software that turned that handheld computer into a voice terminal using voice over internet protocol. So today, if you are running Skype on your iPhone, we were doing the first predecessors of that 10 years ago.
Thanks, Marvin. It was another exciting project.
At this point, I want to throw it open to questions from the audience. Do you have questions about the directions of I&I, about the sorts of things that students do, your own experiences that you want to share? No one? Yes.
So this is open to anyone that really wants to answer it, and I'm curious to know, since we have pretty much many different subsets of telecommunication represented here, so what do you think the next major sort of paradigm or leap in your industry will be toward?
An excellent question. Jesse, you want to start with that one?
Oh, sure.
I'm going to ask everybody to take a crack
right.
at that, not hoping to pick on you, Jesse.
Yeah, no, I think one of the things that is certainly happening in the game industry is connectedness. Already people have been sort of surprised and delighted by some of the things that have been happening in terms of gaming and connectedness. The whole concept of Facebook gaming really took the world a little bit by surprise, I think, this past year. And the part that people seem to like about it so well is it's built off of your existing social network, so that it just removes barriers between you and your friends, because that's one of the things that games are certainly for. And I think we're going to see more and more of this. I think it will become a normal thing very soon for you to boot up your game console and immediately just be connected with all the people you've already made friends with on Facebook or Twitter, or whatever's going to be the dominant social network. And I'll step out and say 5 years from now, I believe Facebook will still be the dominant social network. I'll just I'll be back here in 5 years, and you can all say, "Look how wrong you were." But I don't think I'm wrong about that. So certainly issues of connectedness, and a lot of that connectedness is going to come through mobile technologies, and specifically, I think a lot of it's going to start to come through disposable technologies. We're going to end up in situations very soon where we're going to have wireless connectivity in things that we didn't spend $300 on, but rather on things that we spent $20 on, or $10 on, or $5 on, because Moore's law is still in effect. These things are getting cheaper and cheaper and cheaper, and so it's going to become very normal for everything in our lives to kind of have some level of connectivity. And one of the things we're already seeing in terms of gaming is weird, unexpected connections between these virtual economies, which are very powerful psychological motivators for people, and actual economies in the real world. A concrete example of that would be Microsoft has been trying to get people to use their Bing search engine, and one of the things that they recently did was they cut a deal with Zynga, where they said, if you become a fan of the Bing search engine, we'll give you 3 farm cash. So it's virtual money they're going to give you in the Farmville game. And this drove significant traffic to the Bing search engine, more so than any of their other advertising campaigns, more so than their television ads or anything else, because it was a situation where people were right there able to use the product. And I think we're going to see a lot more overlap. Once the grocery stores start to wise up about how valuable the data they have is, and they're going to start to realize how they can connect that to virtual economies and things. So I think one of the things we're going to see in the gaming world is gaming coming out of its normal places and kind of weaving itself through all the parts of our lives.
Bria?
So I think as an extension of some of the things that I've said, and also some of the things that you've heard on the panel, you've seen over the last maybe 3-4 years this thing called cloud computing and data centers take off. But if you look at it on mobile phones are growing larger. There should be a day when you can essentially create a virtual data center out of all the phones you and your friends have access to. That would be really cool. If in fact all of your data, all the bits in your life was stored on some mobile device, and obviously that you need, those are the high bandwidth, multimedia intensive applications. Going back to my sports thing again, right? So one concrete way then that you could exploit that is, think about the guy who's right up there next to the glass, right? He can see a player's face smash up against the glass better than anybody else. He can see that fight better than anybody else. There's no camera down there, right? But if you could co-opt the phone of the guy who's sitting right there, who has that premium seat that you can never get your hands on, or at least I can never get my hands on, right? And if you could get him to film that moment, and he could give you the rights to that for that instant of time, so you felt you were in his shoes, now you've got something cool. But you can't really do that today, because you don't have the network fabric to support that kind of high bandwidth intensive application. You can do some things like mobile streaming video indoors. We've done it for thousands of people, but we can't yet do that. We can't yet create a mobile data center just out of phones. Going back again to the example in Haiti, right? If you could just take the phones of all the people there and create a virtual data center that allowed them to share information on the fly, creating a data center. Essentially on the fly, creating a mobile cloud computing environment, that would be cool. That's something we're working on already at CMU. Across our campus testbed, we've deployed a number of phones that we're hoping will turn into one of those kinds of mobile cloud computing centers that we will then actually try to deploy in a real life stadium. And we want to see what the effects of that would be. But again, I think that's a huge trend.
I don't know what to follow with that. Because I actually was thinking about the cloud computing, hadn't quite gone to the face against the glass, but this is CMU, so they go there before you do, right? So I definitely think that wireless capacity, everybody's putting a chip in everything. And the more we do that, and it's really about enhancing our lives. And for some of us, it's an enhancement. Some of us, it's people can find us wherever we are, and we're not sure that's enhancing it, right? But how do you get people what they need, wherever they are, whether you're talking mobile, cloud computing, or getting information to customers? I think it's a speed. How do you build the infrastructure? How do you build the software? How do you build the applications that are going to enable, and so such that you have open interfaces, because that's one of the challenges that we have in a competitive environment. You want both open, but you still want your competitive edge, right? So how do you leverage that for the customers, yet still make it a profitable business model? And so this notion of computing from a telecommunication perspective, and cloud computing in particular, is very attractive. For at least the person that gets there first and do it best. For everybody else, it's going to be a challenge.
Marshall, let me ask you one question. Increasingly, we're seeing people talk about devices other than phones that are going to be enabled for cellular. The Coke machine that automatically calls the distributor and says, I'm empty. Mm-hmm. Or the automobile that calls GM and says, this airbag's just deployed. Mm-hmm. Call the emergency people. What's happening with device-based cellular, if it will, and where do you see happening with that?
From emerging devices is what we refer to those at AT&T, and you're talking your Coke machines, or even if you're talking a stadium where the person, I really don't want to move to go order the hot dog and the Coke. How can I enable them to be able to have a device that says, I'm in seat 155, roll, whatever, I want hot dog, Coke, nachos, whole jalapenos, right? And that shows up. Mm-hmm. And there's a lot of activity around that around the world. AT&T in particular are partnering with a lot of devices. We're having forums and consortium with developers to really enable the applications for that. And so I think you know, where that goes is really kind of limitless as you start to talk about the technology. And so we want the partnership with the device folks, but it's really our network that we're trying to harness. And how do we set the network up to be able, where we're talking our mobile network, our IP backbone, the cloud computing, and this is a worldwide network and worldwide issue that we're trying to solve. So the emerging device space is pretty open, and we're starting to see partnership with TomTom and other providers in that arena, but it won't be a phone issue. I mean, we love the phone, we love the iPhone, mm-hmm. right? But there'll be another iPhone. Mm-hmm. There'll be another application. It may not even be a phone, whatever the super gadget may be. So there's definitely some device activity happening, and it's one of those, how far can you push it? And how do you build the right business partnerships to make that work? Because I don't envision that AT&T themselves would build. It'll be an Apple partnership, a Cisco partnership, a TomTom partnership, and leveraging building partnerships so that you leverage what people do best. And hopefully we can talk to some folks at Carnegie about some of the cool research that's going on, and how do we start now to build the network so that as that path develops, we ensure that we're on the right track. I mean, we're leveraging, starting to trial some 4G technology that hopefully is going to give us the capacity to be able to handle these devices everywhere. But there's a lot of work to be done in that arena.
See?
Sure. Well, all of you have witnessed the situation that when you are on the move, you need much more help than when you are in the office. anywhere from your work activities, if they are outside, when you are tourists, when you are visiting different places, that's much more unstructured environment than your regular office space. Now, that's one of the reasons why even today you don't leave your home without cell phone. You try to have it with you all the time. But I would just draw your attention to one application or problem in the future that would mean a lot as a new application for the cell phones. One of the breakthrough applications would be determining person or user intent. I think all ingredients that are needed for that, like sensory support, machine learning support, etc., are present, and that can be done in next, and we are also working on that in the next few years. Now, you can imagine if your cell phone can understand what you need next and proactively bring that information to you, and you have it in time when you need it. I think that would be a great new capability to expect such a help from the cell phone, and I expect that we'll have it here at CMU in the next couple of years.
Yes, come.
Question for Professor Sirbu. What do you think would be a good billing protocol for grid and cloud computing? I worked with Professor Sirbu on a network project from 1996. So imagine all those grids across different countries in different organizations. What would be a good billing solution?
Well, Common refers to a project that we did beginning in 1992, actually, before the web even existed. We envisioned that people might want to download information across the internet, and that there'd have to be some way to pay for it in order to finance people making it available. And we started developing billing systems that could allow you to buy journal articles at 10 cents a page. And you can't use a credit card for something that costs 10 cents because the credit card companies have a minimum charge of a quarter. So we developed something we called the Internet Billing Server. It was re-engineered by the next class and re-engineered for the web in 1994, and eventually became a major research project that we licensed to Cybercash Corporation. Interestingly enough, the notion of micropayments, or being able to bill for something where the billing charge is fractions of a penny so you can sell something for a dime, has not taken off in society at large.
What are you talking about?
The smallest increment typically is the 99 cents for an iTunes.
Oh, in the United States?
Mm-hmm.
What the heck's the problem with the United States? Asia and Europe have the micropayments all over the place. And I don't frankly understand this. I'm hoping someone in this room can answer this question for me. I mean, because in, again, I've got my head in the gaming space, and gaming space in Asia and Europe is completely dominated by micropayments. It's starting to be, any online gaming is happening. And a big part of that is people do they do the billing to their cell phone. You want to bill 10 cents to your cell phone? Snap, no problem. Why is it a big problem in the United States? This is completely beyond me.
People here don't pay their bills on time.
No, really.
Yeah, it's an interesting question. We ultimately did some economics research to try and understand why this wasn't taking off in the information space, and concluded that there were strong reasons why information goods wouldn't be marketed that way. That most of the people you wanted to sell to wanted a lot of information, and for them it was much better to sell a subscription for $20 or $50 a month, and then you don't have to have micropayments. And the advertising industry on the web has been so lucrative that a lot of people find that they can support their websites without any payments, just through advertising. So between the no payment advertising supported and the subscription model, the micropayments model has not proven to have a significantly large niche in the U.S. Well, but I don't understand why we don't have the payments between cell phones like you do elsewhere.
Well, because like, I mean, for example, like by far the dominant Facebook gaming company is Zynga. Everything for them is a micropayment system, which fortunately is made somewhat easier on their system. In Europe, BigPoint is Germany's company doing this. They have and they're having a much easier time. But BigPoint is having a hard time coming to the U.S. because the cell phone companies here refuse to support micropayments, and I don't understand it. It's like they're allergic to money or something. And I have not yet found anyone who has an explanation of why Europe and Asia have this down, but we don't have it here.
May have to do with different banking rules. So it would be an interesting question to take a look at.
I don't know. I don't know if it's a legal thing or a culture thing. It's a mystery to me.
Yeah. So, but you were asking what the payment protocol will be, and the answer is I don't know. But maybe it'll come out of Europe and not out of INI Athens instead of out of INI Pittsburgh.
Grid computing for cloud services with a variety of services available globally.
Mm-hmm.
What would be a good method to handle billing with taxes?
I don't know. That may be the next question we should be looking at.
Micropayment is like e-voting, right? Stuff we talked about in the mid-90s, and it's really taken off quite well.
Right.
You had a question, right? Go ahead.
Yeah, just thinking about the evolution of the field, and I teach 11 and 12-year-olds, and I'm thinking about what they are experiencing at their age and by the time they get to college and be studying and then out in the field. Do you think it's going to be exponential that, you know, what you folks experienced at their ages and where you are, and then...
Yes, absolutely.
I mean,
Absolutely.
The literature says that today's teenagers spend several hours a day being connected, whether it's Facebook or their phones or instant messaging or whatever, vastly larger than any previous generation.
Yeah.
And that's got to change the way they think about interacting.
And it's a very different connecting model when you start looking at that generation, right? So, one, I think I had to get a job before I got a cell phone, but they don't, right? But we have on average that like 10 to 12 send 4,000 text messages a month. 4,000. Can you, 4,000? And I'm just nervous for the day that they start sending video that way. That's gonna drive the network bananas, right?
You guys can do it. Don't be
we can do it.
All right, then what are you worried about?
We can do it, but there's a cost to doing it, and you got to get ahead of that curve, right? So hopefully they don't do it before 4G shows up, but we'll see. So at that kind of volume, right, it's a very different model. And the access that the information that they have access to also drives different behavior. And they're not, even when, like, you know, we got people that were sitting in front of laptops or, you know, in front of their computer doing work. They're doing this gaming and from handheld devices. And so it's going to be a very different connection model that from a teaching perspective, they I think need to understand the technology. There really are no limits to where they're going to go. We just got to figure out now how to build the infrastructure to enable them to do what they're going to be asking to do 10 years from now.
It's a new culture, and all that social networking and use of technology is clearly changing their life. As I said earlier, cell phones are wearable computers. They are computers nowadays. And the way youngsters interact with them and use them for several hours a day, it's clearly a new quality in their life, assuming they are using that for you know, positive purposes. Now, there are also some more intelligent applications that can be built and used by them anywhere from, you know, the all capabilities now that they can have on their cell phone. What are cool places in Pittsburgh tonight for their age? It still doesn't exist. Hopefully that will also be, you know, in existence in a year or two from now. So there are some more intelligent applications where they can be the users or can contribute, and I hope to see more of that pretty soon.
So I wanted to add one more thing there. So I think there's always a little bit of attention, at least for me, in teaching as technology advances, because sometimes the tools are made so much easier you forget how it works underneath. And you always face that in teaching because you always want them to learn the latest and greatest, but they're never going to learn the underpinnings of something because it has been made transparent. right? And so for me, that's always something to balance. You teach them how to use this, but at the same time, open up the hood and say, this is how it used to be 30 years ago, and this is the evolution. Because if you don't know that, you can't be informed about where to go 20 years from now.
Yeah, we all know electricity comes out of outlets in the wall, and not much about what's behind it. Well, we've used up our hour, I'm afraid, and I want to thank our panel very much for, I think, what has been a very stimulating session, and thank our audience for very good questions.